Okay, so today we're going to do a little bit of cumulative review, but the focus for today is going to be on word problems, right? So we're just going to look at a bunch of word problems that have to do with a bunch of the different concepts that we've covered so far in this course. So here we go. So like I just said, focus is on word problems today. I'm going to introduce a useful strategy. We've not really used this strategy before. It's for solving word problems. I'm not going to force you guys to use the strategy if you don't want to. There's no sense in doing that. Some of you already have strategies that work just fine. But it is just another tool for your toolbox, right? So if it's another tool you want to use, go for it. If you don't want to use it, that is fine as well. But I think some of you might benefit from using this. Now, you should be trying each of these problems on your own first. So even though I am introducing a new strategy for it, it would be a good idea just to sit down and say, hey, let's see how I can do this one first. I think there's only 4 or 5 problems we're going to deal with because we've covered all this information before. So anyway, let's get rolling. So the strategy is called the cubes strategy. Each of those letters stand for a different step. The C in cubes stands for circle the numbers. So if you circle all the numbers, even if they're like actually like spelled out, like if I said 3, like THREE, right? Circle that as well, because it might be useful. The U in cubes is underline the question. So whatever the question is, if you underline that, that at least gets you focused on that. And then box the keywords. Box the keywords. So keywords could be like, I don't know, twice something or of something or anything like that. Just anything that looks like a keyword that might help direct you towards what strategy to use. E is eliminate extra information, but it's also evaluate. What steps do I take? So when you look at the E step, this is usually the most challenging step. See what information is too much. Like, is there anything that you didn't really need to know and you can just cross it out and eliminate it? But the E step is also about like figuring out what strategy do I have to use, right? Or in other words, what procedure is going to connect. I highly advise you look at your keywords that you boxed, because your keywords are usually the ones that are going to indicate what your next step is going to be. The last step for S is solve. And of course, often a good idea to check. Does the answer make sense? Go from there. You don't have to use a strategy if you don't want to. It's just we found it and we thought, you know what, like as a whole department, we found it and went, you know what, this might be a good strategy to use. It might help some people. I'm going to see how it works for these first couple questions. Anyway, here we go. Question number 1. Darcy has 3 times as many nickels as he has dimes and twice as many quarters as he has nickels. In total, he has $8.75. How many of each coin does he have? I put the cube strategy picture there. You can try it if you wish. Either way, regardless of how you want to go about this question, I suggest that you pause the video, give it an honest try, and then I'll go over it in a second. All right, so I'm going to go over this one now. These are challenging questions. I started with a pretty tricky one right out the gates here. I'm going to try using this cube strategy, though, just to see how well it works for me. The C in cubes stands for circle the numbers. So I see it says 3 times as many nickels, so I'll circle this, even though it's not literally a number, it's just a written out number. That works just fine. And twice as many quarters as he has nickels. That actually might be useful too. Twice, 2 times, in other words, 2 times as many quarters. That might be worthwhile to circle. In total, he has $8.75. That's a number, obviously. Circle that one. So I would say this step of the cube strategy is all done. Underline the question. How many of each coin does he have? I'm only going to underline that section of it just there. That's all well and good. Box the keywords. Keywords here are going to be things that kind of clue you into context here. I would say the fact that it was nickels, dimes, and quarters, those are pretty keywords. Nickels might be a word I want to box. Dimes might be another one I want to box. And quarters might be another one I want to box, right? You could box nickels again here too, but I'm not going to worry about that. So for boxing keywords, we're done. Eliminate extra information. It's often hard to tell whether information is extra or not, but just looking through this whole question again, I think the only extra information is, boom, we don't care about Darcy. It could have been anyone. I don't know. You didn't actually have to cross that out. Extra information isn't always given, but it's always a good idea to see if you have any extra information. Now, we got to evaluate this, right? What steps are we going to take here? Well, if I look at my keywords I boxed nickels, dimes, quarters. It's probably useful to understand how much each of those are worth, right? We know how much money we have in total here, $8.75, but a nickel is of course worth 5 cents. A dime is worth 10 cents, and a quarter is worth 25 cents. So that might help lead us to something here. Now, if we look back at what we've circled, 3 times as many nickels as dimes and twice as many quarters as nickels, it seems like everything, if you think about nickels being twice or 3 times as many as dimes and quarters being twice as many as nickels, it seems like everything kind of comes back down to dimes here, right? Dimes is going to be the number of coins that we have the fewest number of. So how about we do this? How about we say that X equals the number of dimes? If X is our number of dimes, then 3 times that is the number of nickels we have. So we could say 3 times X equals the number of nickels. And now the number of quarters we have is going to be twice as many as the number of nickels. Well, the number of nickels we have is 3x. If you times that by 2, 3x times 2 is 6x. 6x is going to be the number of quarters. Okay, so now we're getting somewhere here, right? You can see why E is such a strong step here. It's really just getting us started doing all this other stuff. So if X is the number of dimes and 3x is the number of nickels and 6x is the number of quarters, how about we now try to connect this with the value of each of these coins? Because we know nickels, dimes, and quarters here, those are important contexts to have. Since X represents the number of dimes we have, we could say that the total value of our dimes is 10 cents multiplied by however many dimes we have. So 10 cents, I'll fix that, hold on, 0.10, 10 cents multiplied by the number of dimes we have. That expression, 0.10x, represents how much all of our dimes are worth. If we add this to 5 cents, the amount a nickel is worth, multiplied by the number of nickels we have, that tells us how much our nickels are worth. Plus, if we multiply, or rather add this to the amount a quarter is worth, 25 cents, multiplied by the number of quarters we have, that expression right there tells us the value of our quarters. All of those coins, the dimes, the nickels, and the quarters, all of those coins added together is going to give us a grand total of $8.75. So again, this is the value of our dimes. This is the value of our nickels. This is the value of our quarters. And the value of all of those coins added together is $8.75. Notice since we based everything off of dimes, we can now collect our like terms here. In other words, we can collect all of our x's together to get an expression just in terms of x. Now, 0.05 times 3x, that can be cleaned up here. Hold on, I'm just going to go 0.10x plus 0.05 times 3x would be 0.15x, because 0.05 times 3 is 0.15. Plus 0.25 times 6 is 1.50x. And if you don't believe me, you could have always used your calculator on that one, no problem. This is still all going to equal 875. Notice we have certain amounts of x's all added up together here. If we add those all together, we're going to have 1.75x equals 8.75. To wrap this up here, to find our x, we just need to divide by 1.75 on both sides. And that gives me x equals 5. And just remember that x represented the number of dimes. So we could say that is how many dimes we have. The number of nickels we have is 3 times as many dimes. So we can say 15 is our nickels. And the number of quarters we have was twice as the number of nickels. So twice the number of nickels here would be 30. And that is going to be how many quarters we have. So I don't know if the cube strategy helps so much here, but again, it might just be a good strategy to help you get started, to break a question down and not worry about how much stuff is in there. Anyway, we're going to move on. Got a couple more questions we'll do here. These ones shouldn't take quite as long each. The next question says the population of bacteria in a Petri dish, that's like this stuff right here. You can do like a little swab in there and then bacteria can grow, triples every 6 hours. If there are 15 bacteria now, how many will there be in exactly 3 days? You can pause the video here, give this one a try. All right, I'm going to go over this one now. Let's start by circling our numbers here. I see the word triples. That's kind of a number word. Circle that one. Every 6 hours, that's another number to circle. 15 bacteria now, that's another number to circle. How many will there be in exactly 3 days? Yet another number to circle. We got a lot of numbers going on here. Next part of cubes was underline the question. How many will there be in exactly 3 days. That's the underlined part. Keywords here. Don't think the fact that it's bacteria in a Petri dish really matters, but I guess a keyword, it kind of bundles up with our numbers thing, is triples. I'm going to erase that circle around triples and I'm going to change that to a box because maybe that is more of a keyword. Triples every 6 hours. If there are 15 bacteria now, how many will there be in exactly 3 days? I think that's pretty much it for keywords. It's tripling every 6 hours. Maybe our units might be nice though. Hours is one of our units and days is another one of our units. Just keep in mind in math and in science, you really don't like having mismatched units. So that might be something to keep track of. So now that we boxed that, I guess the next step is E, to evaluate. We're looking for how many there will be in exactly 3 days. Remember what I said just a second ago about mismatching units. The fact we have 6 hours and 3 days and stuff like that, those units don't match. Let's remember that 1 day is 24 hours. So 24 times 3 means 3 days. But I just scratched this out. 3 days is actually 72 hours. And at least now we have hours matching with hours. Since the bacteria is tripling every 6 hours, that means it'll triple. So it'll be 3 times as many after 6 hours, and then it'll triple again after 12 hours and triple again after 18 hours and so far. I guess we could ask ourselves, how many times does 6 hours pass in 72 hours? Well, if we go 72 divided by 6, that should tell us 72 divided by 6, I believe, is 12. That is 12 times that this bacteria is going to triple. That's pretty crazy, actually, when you think about it, that happens 12 times in just 3 days. I guess the next thing is, since it's tripling 12 times, you could go 15, the amount of bacteria you have, tripling, so times by 3, 12 times. So times by 3, 12 times. Was there a nicer way to write this? 3 times itself 12 times? Well, I hope you say yes, because yes, there is. 3 times itself 12 times, you might as well write that as 3 to the power of 12. So 15, your starting population, multiplied by the fact that you're tripling 12 times. I'm going to need a calculator on this one. I expect the number is going to be really, really, really big. Yeah, it is actually really, really big. That is going to equal 7,971,615 bacteria. And I'll put those little commas in there to space that number out. That is how many bacteria there will be after 3 days. That is insane. It tripled every 6 hours. That really gets out of control. I don't know if it's necessarily fully realistic that that happens exactly like that, but it is a good trend, certainly, that things do have exponential growth just like that. The picture right there, by the way, that was interesting. I saw that not too long ago. It was an experiment where they did a Petri dish where someone coughed over the Petri dish with a mask on, and then the same person coughed over another Petri dish without a mask on. Certainly made a big difference, right? Anyway, that's my plug for now. Here we go. Next example, Shauna was flying a remote-controlled airplane in a circular path with a radius of 50 meters. The signal was suddenly lost, which caused it to fly tangent from the circular path until it crashed 140 meters from Shauna. How far did the airplane travel horizontally along its tangent after it lost the signal? Pause the video here, give this one a try. You'll want to jot a picture down on this one, believe me. All right, I'm going to use the cube strategy once again. Let's circle any of our numbers here. I see 150 meters. I can circle that number. 140 meters is another number I can circle. That's about it. Next step of the cube strategy is underline. So how far did the airplane travel horizontally? So that kind of tells us we're looking for that tangent line. Then box any keywords. I think the fact that it's a circular path, that's a keyword. Tells us we're going to be dealing with circle geometry here. Tangent is a keyword. That's a really good keyword, actually. It crashed. I don't think those are keywords. Along its tangent, I could box that again. I think we're good on that one. So then the E step, eliminate any extra information / evaluate. A lot of the words here are extra information, like the signal being lost or the fact that it's an RC airplane, all that. I won't worry about knocking that out. I think the number one thing here is to draw a picture. If we drew a picture of a circular path, I'm going to do my best. Oh, that's a gross circle. You know, I'll try that again. Here we go. Just go fast. Okay, good enough. That's our circular path. The airplane's buzzing around, and all of a sudden it lost its signal. Let's suppose it lost signal. You know what? Right here is where we lost signal, and it just kept on going. Notice that is a tangent line to our circle, because if it's going and going and going, it loses signal. It's just going to keep on going in a straight line until it crashes. We know it crashed 140 meters from Shauna. Shauna, we can assume, is the center of the circle there. I guess we have to. Oops, I really should have put that in the question. Sean is at the center of the circle here. Sorry, guys. Oops. But anyway, assuming she's 140 meters from that crashed airplane, we can do a diagonal right there, 140 meters. And we know the radius of the circle is 50 meters. It says, how far did the airplane travel horizontally along its tangent? So that would be from where it lost its signal. That's this, we'll call it just X right there. Okay, hopefully you notice the tangent line, that's going to be a 90-degree angle there. Inside of a 90-degree right triangle, you can use Pythagoras to find missing side lengths. Our hypotenuse is this 140, so that's going to be the side all on its own in Pythagoras. So we'll say 50 squared plus X squared equals 140 squared. And again, 140 squared is by itself here because it is the hypotenuse. It is across from our right angle. If we square these out, 50 squared, give me a second here, 50 squared is 2,500. Oops, not equals, plus X squared equals 140 squared. This is going to be a big number, 19,600. We want to solve for X squared, so let's minus 2,500 over. So X squared equals 19,600 minus 2,500 is 17,100. Now we got to square root both sides. This is actually going to give us our final answer here. If you square root this, you know what, just I'll round to the nearest tenth because it's a gross number. We got 130.8. And I guess the units on that would be the same as the units in the rest of the question. That'd be meters. Wow. Okay, so a picture was worth 1,000 words on that one. Cube strategy was actually decent on that one. I actually liked it because it actually told us we were dealing with circle geometry, and it told us straight up that we had a tangent. Again, if you don't like the cube strategy, don't use it. I'm not worried about that. It's just another strategy you can use. I know it will help some people. I think this is the last question here. A rectangular field is 15 meters longer than twice its width. What is the expression for the area of the field in terms of the width W? Expand the area expression in your final answer. Okay, so pause the video here, give this one another shot. I'll go over it in a second. All right, first things first, cube strategy here. We know 15 meters longer than twice its width. So how about I just circle 15 for now? Twice might be a number I can circle. I guess that would be about it for numbers here. For underlining, we're looking for what the question is. What is the expression for the area of the field? I'm just going to say expression for the area of the field. I'll put another line under area too, just to really highlight area is what we're looking for. Remember, the area of a rectangle is length times width, so that might be useful. Box keywords. I think a keyword is the fact that it's rectangular. 15 meters longer than twice its width. I'll box all that because that seems all important. I guess area is another keyword. That's about it there. So to evaluate this, first of all, we have to come up with some sort of an expression here. So if I drew a rectangle, obviously a lot longer than it is wide, it wants this in terms of W. Maybe I'll box that too. W is our width. Notice it says the field is 15 meters longer than twice the width. Well, twice the width would be 2W. 15 meters longer than twice the width would be 2W plus 15. So we have 2W plus 15 as our length there. We want an expression for the area of the field. Well, area is length times width. The length of the field, though, we know is 2W plus 15. So we can say area equals 2W plus 15 multiplied by W. And I guess the only last thing we have to do here is it does say expand the area expression. Maybe I should have underlined that as well. Expand the area expression. When we say expand, we just mean don't have something times something. Multiply things through. Notice this W, the width, all by itself on the outside here. That can double dip its way through this. So this is going to give us area equals 2W times W is 2W squared. Plus 15 times W is just 15W. And that's, I think, all that one was really looking for there. That was actually a pretty quick question. Hopefully don't get caught up too much in the wording here when we say 15 meters longer than twice its width. Just try to break it down like that. 15 meters longer than twice the width. So twice the width is 2W, 15 meters longer plus 15. These are the kind of things that just come with a lot of practice, unfortunately. And that leads us to our Cumulative Review 3 booklet. Remember, I've got that posted on Google Classroom. The answer key is also found on Google Classroom. Make sure you are using that wisely. Check it over. Make sure you're checking your work here. Practice is absolutely essential in all of this. You are not going to get too far without it. Anyway, as usual, if you have any questions, please reach out for extra help. Anyway, good luck.